All right, so for loading, we're going to have our, get up there, we're going to have our hex value of whatever val was passed in. Then we're going to load it in reverse, okay? And we're not going to worry about high and low right this exact moment. Actually, we could. Because load high. Well, let's just do the normal one for right now. Okay. So we have our move. Here's our register. We're loading into this register the value that we got out of our parts get to. That's the, in our case right now, the immediate value. So parts get to should be the immediate value we want to load in there, and whatever format it is, we're going to load it into the register that we found. And right now we're assuming we're using the full register, not the highs or the lows. Okay. So this is for process instruction.
The replacement Galaxy Note 7s that they sent everybody
Are you serious? Wow. See, the other ones at least they got a little warm before they lit on fire. These, it just comes out of nowhere. Are you sure it's not like a joke site?
Positive.
So they recalled a zillion Galaxy Note 7s and then sold them exploding ones, sent them exploding replacements? Like it was already melted. The injury is barely healed.
I think the best joke I heard about that was, it's someday, one of these days, the iPhone's going to blow up and the Android fanboys are going to say, oh, we've had that feature for years.
Yeah. That's a good one. Well, actually, I mean, I have a buddy who, I don't remember which iPhone it was. I want to say maybe like the 5 or 5S, that vintage. He had it in his pocket, and I mean, I don't know if it caught fire or not, but
really hot. They had a problem with it getting really hot.
I mean, really, he got burned.
Yeah.
I mean, he had a burn on his body. I mean,
no, they had one batch that got really hot.
Okay. I mean, like he had to go to the emergency room burn, not just like, oh crap, what just happened? It was he got injured from this thing.
Hopefully, it was more on the side of his leg. You know, the closer it gets.
Yeah. Well, he's already had all his kids he's gonna have, so yeah. He's like, I don't know, late.
I was done with it.
Yeah, the ship has sailed. But yeah, so I mean, it's electronics. It can happen to anybody. It's just kind of unfortunate that Samsung's first of all had to go through it once, and now it's not going to do good things for their stock price. It'd be brought up on like attempted murder charges.
Yeah, it's like the airlines started telling people, do not bring your Galaxy Note 7s.
Oh yeah, they announced it at every flight.
What? Like airlines were telling people, do not bring your phones on the plane.
You have to, and if you have it on there, you have to power it down and not plug it in. Can't be charging.
Because fire.
Yeah.
I can just imagine. It's like.
All right. So what we want to do now is we want to have, after we process a command, we want to go ahead and show the value of our registers, right? So this guy should always show the value of our registers after a command. All right, so that means that for each of our general purpose registers, we want to go ahead and have a get value type thing that just shows us the value of both high and low. So probably like as a 2-string type thing. So let's go in here and let's do.
the arrays, won't they air out or no?
What we can do is after we do the value here,
Yeah.
so we can say this dot. See, this is a character array, so I think it's arrays dot fill char array. So this dot value with zeros. I think that'll fill that array up with zeros, so it defaults to that. And then what we can do here is we can say, what is it? Public string to string. We want to get that array into a string format. That's going to be easy enough, so we could just return new string from this dot value. Just convert our char array into a string. I don't know if I want to do that as a get string or as a toString, allowing us to print out the.
Wouldn't you just want to print all the states of the registers after a command?
No, we are. This is just for an individual register. I'm just wondering whether I want to leverage the toString method that's built in, or I want to have a a get value that returns a string. I think I want that.
Are you gonna have a separation between the high and low?
I will. I will eventually. For right now, let's just get the value showing up. So let's call this get value. All right. So then what we'll do we're going to be inside of main activity. All right, so that's our output text, which actually we don't need anything there. We don't need that to output anything right now. What we want to do though is we want to have all of our registers. So we're going to say this dot, didn't I give a name to that guy? Oh, we didn't. We didn't give names to those guys yet. Hello.
What?
These guys.
Do we? Or do not?
Yeah, I didn't give a name to it. So AX reg ET. BX reg ET. CX reg ET. DX reg ET. And then let's give ourselves access to those guys in here. Private edit text. Okay, those are those guys, and then say this dot AX is equal to edit. Actually, why are these edit texts?
I was wondering. Those should be text views.
Yeah.
Good.
before I do that, let's fix this. It's going to be faster just to do it out here. Ay, ay, ay.
Ay, caramba. Ay, papi.
Now I gotta.
Sí, papi.
I don't want to have to recopy this. Wait, hold on. What happened? CX. Okay. Let's just grab one of those guys there. I typed in a lowercase, I promise. Android or whatever studio felt that I meant something else. Okay, so that hooks them all up. Then here, after we what we need to actually process our, so we don't even need this here. We're going to say CPU dot process instruction parts. So we'll pass in the parts that we're going to process. Then we're going to update our registers. So let's write a little function here. Private void show register values, good enough. And we'll say this dot AX we want to do this. Nah, we can try to be fancy with it, we just do it. So we'll say dot set text, and the text we're going to set it to is CPU dot registers dot get AX, and that guy is going to be a general purpose register dot get value. Light rain is stopping. Followed by another beep flood warning. Alright, so this will be BX, CX, DX. Okay, so we'll show our register values there. We also want to, let's go ahead and show them initially as well. So they should all have zeros in them to begin with. So after we press our emulate button, it'll grab the instruction, it'll get the parts out of it, process the instruction, and then show the updated state of our registers. All right, so let's see what that guy looks like. All right, so there's all of our zeros, our initial state of our registers. So let's move AX, comma, 17. So there's an 11 in AX. And let's move into BX. 1 1 0 1 1 1 1 B. So there's our 6F. Looks probably right. Come on, math people. Move. Yes,
I actually.
just do it with confidence.
No, it was 4 ones and then 2 ones.
I believe you. I do believe you. It wasn't like that long of a binary number. No matter whether you know it or not, just say it with confidence. It's the art of teaching. We just captured. When you're pretty sure you don't know a concept, you're best off saying that I'm not sure. When you're pretty sure you know it, pretend like you completely know it, and just roll with the punches. I think that might be some kind of secret of teaching. Because what's the worst that happens? You get class filler. You have to spend a bunch of time thinking about something, and like, well, now the class is filled up with material because we really had to debate the issue. All right, so CX, let's do a hex value. So 0x BAD. So that should be legal enough on its own, right? So this should be 0 BAD for the contents of the register. Yep, 0 BAD.
Well, I mean, the bad thing is if you do put a 1.
Pun intended. The bad thing.
If you put a 1 in front of B, it's going to air out. Because
It's larger than a 16-bit register can hold. Yeah, which it should.
Okay.
Yeah, I mean, that's, if we give it a value, I mean, when we start implementing our flags.
No, but what I'm saying is the 0x, then you put what should be a 16-bit number. So if you put a 1 right there, it's going to air out.
So this is the ones place, the 16s, the 256, the 4096. So that should fit entirely inside of a.
Put that 0 in front of it also throws it off.
This shouldn't error out. Oh. Putting this into, when we put this into DX.
Because it
Time to use those magical breakpoints.
wait, but that because we're not storing that 0 into any place then. That beginning 0.
Well, so the issue seems to be that 01 BAD doesn't convert correctly.
It's too long.
But
0.
Oh. You're trying to put like 5.
But
Yeah, because I don't need to convert it.
Yeah.
But I'm doing it based on O.
But I mean, but don't we have it set up so that it shouldn't air out? Because even if the string's long enough, it's only filling that certain amount of bits.
Let's look at how I'm filling it. Am I counting off the size of the array, or am I counting off the length of the string? I think the size of the array.
This value dot length, which is the string that we're bringing.
Where is this in general purpose? Is this guy? Load?
And then for the array, it's hexval dot length, which is not the char. Hexval is the string.
Yeah, we don't want that. So we want this guy to go
To the end position, right?
Yeah, because what we tried to put it bucket -1. That's what we did here. So what we need to do is just reverse these. So we'll say n pause is this guy. And then we'll say I starts off at this dot value dot length minus 1. That should work. So same logic, we just operate off of the char array. So we won't try to place more characters than we have spaces in the char array. Oh, let's test it real quick and I'll show you.
It's not gonna pop up.
Yeah, I just recognized that. So ax comma 0x1 BAD, that's a legitimate number. Now it'll load it in there. Okay, so now we need to make this work for our highs and lows.
So, but now won't it still work if we put a number that's too large?
Well, it won't work. It'll fill it as much as it can fill it and then overflow, which would, hit one of our flags. If you try to put a value that's too big into a register,
that if you move it, it airs out.
yeah, that's true.
So at that point, when
You have to make sure that your value isn't too large if you're trying to move.
Yeah, so probably the easiest way to do that is to get the binary string and count the bits to get its length.
Or when it's an integer.
Well, I mean, you could do it with any of them. They're all values. But if you know you have a 16-bit register, you get the binary string version of it. If the length is greater than 16, then this isn't going to fly. Unless it pads it.
I didn't think it padded it.
Okay.
If you put in a negative number as just a straight integer, it'll put it to 32.
I see. Because it'll
Do
do
what?
this.
If you put in a negative
Because
number,
it does the
it'll
twos
do 32
complement.
ones.
Yeah.
I just did it when it was an integer because then it's a strict value
Yeah.
that you have to test the size of.
Is it greater than 2 to the 16th minus 1? Or is it less than negative 2 to the, 2 to the 15th minus 1, or is it less than negative 2 to the 15th? 2 to the scythe value, okay. So that's going to be inside of load. So there's our hex value. So we'll let it go ahead and get the hex value. And then from that hex value, we should be able to parse a decimal value, right? So we'll say if decval is less than math.pow 2 to the 15th and decval is greater than or equal to negative, does that work? I think I just might need to multiply that by -1, be safer. Math.pow 2 to the 15th times -1. if that's true, do this crap. Else,
What's the asterisk for?
with asterisk.
Oh, okay.
This guy? Yeah, I'm multiplying that by -1.
Yeah.
I think you could probably just put a minus in front of it, but just in case. Let's see. Well, let's just do system.err.println value too big. What should we do? So at least we'll remember that to fix it at some point. Okay. Let's go ahead and run that, and then we need to do high and low. All right, so that should be too big of a value, right? I need to get my console. Then this one, what? Terminal? Is this guy? Value too big. What should we do? Okay. All right, that seems good enough. All right, so now to handle high and low, after we search for our registers, so this is inside of our CPU's process. So we ask our register, we ask to get the register given a specific name. So that's only going to return something real if it was AX, BX, CX, or DX. But our highs and lows might still exist. Go ahead.
So, I mean, the highs and lows are inside of AX, BX, CX,
Correct.
DX. But the way we have it set up now is they're just strings. So it's just the name of them. So
Well, the name of them, which also then implies whether it's the first size minus 2 bits or the second size minus 2 bits. So if we have dest is equal to null, dest must be a variable location or a high/low register. So let's figure out if it's a high or low register. So we're going to go through each of our registers. So we're going to say for okay, so for storage S in registers, so for each of our registers, it'll allow this, right? Oh, it's not applicable to a hash map. Can I do like registers dot to dot array enumerate maybe? Dot values. There we go. Okay, so for storage S in register dot values,
The dot values is
so in general purpose register, what we're going to do is we're going to throw another function in here. Public boolean has sub register string name return this dot return name equal, well, that's not the way to do it, dot equals, I guess we can do the equals in lowercase. This dot high name or name dot copy. This dot low name So this will return true if it matches either of those. If the name we passed in matches either the high name or the low name.
But how does that help?
So we know whether or not this is the correct
Oh,
register. But it might be better off if we ask multiple questions. If it has high register, load high. If it has low register, load. Okay, so let's just do this. Has high register, high sub register. Do that. Has low sub register. Do this. All right, then we need to do a load high, load low. So we'll base it off of this. All right, so load high, we get our hex value, we get our decimal value, and this is, actually even this isn't right. It's not 2 to the 15th. This should be 2 to the this dot size minus 1. This dot size minus 1. And this should be this dot size, actually this would be fine, divided by 2 minus 1. This dot size divided by 2 minus 1. Okay, and load high is going to load into the so we're still going to start at the end of our hex value, but we're not going to start at the end of value.length minus 1. We're going to start at value.length divided by 2 minus 1. That's for loading high. So that'll go from that all the way to the beginning. And then load low. It's going to be the same error check for this, but we're going to start at length minus 1 and go up to, as long as it's greater than this dot length, this dot value dot length divided by 2. Greater than or equal to that. Right? Yeah. Start at the last legal bucket and go up to the halfway point. Okay, that's load low. Okay. So now let's go back into CPU. So now we're checking our storage elements here. Now we only have general purpose registers, so we could do something like this. If S is no, it's instance of general purpose register, if that's what that guy actually is, then we'll say if the general purpose register version of S dot has high subregister of this guy. That's a true statement. Then we're going to say this guy dot load high. Load high, and the value I'm going to load is and we can go ahead and break out of there as well once we found the right place. We might want to have a check to see if it Boolean placed is equal to false. Place is equal to true. Place is equal to true. All right, so we'll go through each of our general purpose registers. We'll ask each register, do you have a high subregister named this? If yes, load high, our value, place equal true, breakout. Do you have a low subregister named this? If yes, load low, that value, place is equal to true, breakout. Otherwise, loop through, find the next guy. And this is only if we're looking at general purpose registers for our storage types. After this, if not placed, we have not found the destination. Well, actually, if not placed. No, destination must be a variable or doesn't exist. One of those two. All right, and our homework's going to be for the variables, so we're going to just leave that. I'll leave that as a placeholder for right now. All right, so this should work for high or low. So let's go ahead and run this. Ruh-roh. All right, so let's move into, let's just make sure we didn't break anything else. So let's move into AX 0x BAD. All right, there's that guy. Then we're going to move into here, BH AC H. That should be B high. Oh, I gotcha. So 0x. What do I have in there? I understand. I get it. I get it. I'm using the other form now. What was the value I tried to put in there? AC. Okay, let's see what error message that's giving us here. Value is too big. Well, AC should not be too big. 16. Register. It's an 8-bit half. Those are 4 nibbles. Yeah, that should work. Okay, so Y. That has to mean that my check here for load high. If the decimal value 2 to the size divided by 2 minus 1. So if size is 16, that should be 8 minus 1 is 7. This dot size divided by 2.
it's parsing a hex value to a decimal to an integer, it's not gonna check. It'll be the straight integer. It won't check if it's signed. Right now we're checking. If it's a straight
Oh,
integer, so
well, that still shouldn't have broken what we just did, because I used a positive number.
right, but a straight positive number takes up an extra space. Whether-
Well, integers are signed.
No, it shouldn't take up an extra space.
Integers are signed. Because you can store a -4 in it.
Right, but when you
Actually, do
parse
we
it-
even need
when
to
you
do
parse
this?
it to an integer, it doesn't care. Like it takes the unsigned value.
Can't we just take the hex value and divide it by the length of the hex value divided by 4 and compare that to the size of our register? Rather than do the decimal thing? I mean, they should be the same. We're doing the same math. But this guy says it's too big. So AC,
So breakpoint.
well, we know where
Right,
I mean, we know exactly what line it's on because I moved into BH. So that's high.
Couldn't you just check
So it's right here.
It'd be hex val, the length of it is what you would check. Because the value of it, hex val that length, you'd only want it
Why
to
would
be 2.
you not convert it to binary? Take the
Well, we can't. It's all the same. They're all numbers. So it doesn't matter whether we're doing it in base 2 or base 10 or...
If you take a binary and then you take the binary number, you should be able to split that directly down the middle. And then you take the high and the low.
Right, but that's not where we're failing. That's not where we're failing. We're failing right here where we're saying, is the number too big?
Okay, so what?
We're getting the
Right,
answer
but you
yes.
shouldn't have to do that if you're doing the binary one.
Or you can just do hex and if the length of the string is greater than 2.
Well, I agree, but that should be identical to this. That's just the 6. That's the base. Well, so we have an error here. So this value must not be the right value.
It isn't -1.
So if it's less than, no, because it would be -128 to positive 127 would be a base 8. I'm sorry, an 8-bit register. The range of
You can go
values
to 255.
only
Because
in.
when it parses a hex to an integer, it takes that as unsigned. So -1 would be.
Right, but
-1 is.
we can't. How are we going to designate?
If you give a negative, is it -1 will parse to FF.
Well, I guess for right now, let's forget about negatives. We'll have to add the ability to do negatives into this because that's going to be the 2's complement stuff. But for right now, we haven't tried to do a negative. So we tried to put in AC, which should fit in there.
You have
And-
it set up to make sure that a signed integer is in between the signed range.
I understand what you're saying. I get what you're saying.
So we have that
So-
extra bit to work with.
I gotcha. So that -1 thing is correct if we're dealing with signed numbers. I got it. So really, if we want to stay kosher here, both of these guys should have the -1 taken off.
But you take the -1 off if you're checking if it's less than. So you check the first one, is it less than the greater
Oh,
than-
right. But it's for all of them. So that -1 is gone. This -1 stays.
Yes.
This -1 is gone. That -1 stays. This -1 is gone. That -1 stays. So move into BHAC. There's our AC. Move into BL. EF. There's our EF. So that seemed to load high and low. Two H, and let's do This is going to be a 8-bit, so 255 should be the largest. This should put an FF in AH. Yep. Okay. So does this seem to pretty much work for positive numbers across our 4 main registers? Okay. So what we need then for our next step, in your homework assignment, how many of you made it work for negative numbers? Well, you would have had to purposely have done it, because you would have had to map it in 2's complement.
Let's find out. Let's see, like 6 years to download this, but let's find out.
Is Max soon starting better than the launch?
So what we want to do then for our homework assignment, I'll go ahead and upload this code so you have the newest version. So let's commit changes. This is code from class 9/27/16. Commit and push. Okay, so that code should be up there. So for our homework assignments, so he'll have to do a little bit less. Make sure that it works for our 4 general purpose registers for positive and negative values, and then also add the ability to have a variables be your destination. Our source values for right now should all still be immediate values.
What's the how do you name the variable though?
Because we don't have a define statement. Well, no, I mean we really should. Well, it's an interesting question because it's a halvesy thing. If we're going to define a variable, for right now, let's do it this way. Since the destination can only be a variable or a register, we already wrote the code is it a register? Is it a sub-register? If it's neither of those, it must be a variable.
Okay.
If the variable doesn't already exist, create it. We'll automatically create that variable name. So our destination can be any of our registers, either full or sub, or it can be a variable. And the first time it tries to use a variable, we'll just create the variable. So you're going to create a variable environment, probably using a hash map, very similar to how we did registers, right? And then also make it work for negative numbers, which means you'll have to use 2's complement for storing things. And then you look at the first bit, the far left bit, to find out whether this value is a positive or negative number. If it's a positive number, then you get the full storage capacity. If it's a negative number, you'll have a 1. In the far left bit, that means it's 2's complement. Make sense? All right, so I'll put up the Dropbox for this, and I'll put the link up for this again, but this is the same GitHub link as you had last time, so you can use the code from class. So if your version of the project is up the creek, and you want to start from this one, that's fine. Otherwise, you can incorporate these changes. Otherwise, if you're happy with your current one and it doesn't deviate horribly from our version of this, that's fine. Just roll with yours, even if it works a little bit differently. All right, I will see everybody on Tuesday. And again, no paper this week because I think this is going to be a substantially reasonable amount of work. Although if you've already done 2's complement, you probably will have less work this week. Because that was probably the hardest part.
I wasn't using objects though, so I have to.
Well, you don't have to. I'm not going to take off points for bad programming practice, but for self-development, because we're not approaching this as a programming assignment, we're approaching it as an architecture assignment. So we're thinking about, how we would have built it. So, if you didn't use objects, it's not the end of the world, but
I'll just switch over to it because you already have it.
okay.